All right, so I want to look at one particular graph and express its equation in both polar and rectangular coordinates. So we want to write the equation for the graph of a circle centered at the origin with radius 3. So 1, 2, 3, quick sketch of that. I don't know, that's good enough. Okay, circle centered at the origin, radius 3. So you may recall from your algebra days that the standard form for the equation of a circle centered at the origin is x squared plus y squared equals r squared. Oops, equals r squared. Maybe the general form sticks out in your mind more. I'll write this down just in case. If the center is at coordinates hk, then, so the general form for a circle centered at hk, radius r, is x minus h squared plus y minus k squared equals r squared. So when the center is the origin, 0, 0, this becomes x squared plus y squared equals r squared. I bring this form up only to jog your memory if that helps you recall, your circle equation writing and graphing days. So anyway, centered at the origin, radius 3, that just means we need to replace the r here with 3. So x squared plus y squared equals 3 squared, which is 9. So there's the equation in rectangular coordinates. So a couple of ways of coming up with the polar form for this equation. One is to recognize, and this is going to be a key thing, you guys who are going on to take Calculus 3 are going to want to file this away in your long-term memory. X squared plus y squared equals r squared is a conversion equation for converting between rectangular and polar coordinates. So we could just take this equation we just wrote, if we feel pretty confident about it, and just convert it using this fact here, x squared plus y squared equals r squared. So convert it to the polar form. So r squared equals 9, or r equals 3. So r equals 3 is the equation of a circle centered at the origin with radius 3. And I want to talk about that just so we can make sense of it. So so let's say we were just working from that equation, r equals 3. So this equation has no restriction on theta. Theta can take on any value. But we want points that are 3 units away from the origin. And so that's exactly what a circle describes. It's the collection of all points that are this fixed distance away from what we call the center. So, and the way the polar coordinates are defined, r is by definition the distance from the origin. So we want the collection of all points that are 3 units away from the origin. Well, so what you're describing then is a circle centered at the origin, radius 3. So it makes sense that the equation r equals 3 would also describe this graph.